Next planet from the sun is Venus. And actually, Venus is the closest planet in size to Earth. Venus is only 94% the size of Earth. So Venus is actually very, very close, at least in physical size to our Earth. But the two planets have radically different surfaces and atmospheres. Oh, and this is a picture where we've got the moon here, and that's Venus. You can sometimes see Venus in the morning time very well, or in the evening time. The reflected spectra and spacecraft measurements of Venus show that the Venus atmosphere, or sometimes we call it Venusian atmosphere, is 96% carbon dioxide, not the mostly nitrogen and oxygen of our Earth's atmosphere. And then if we've got 96% carbon dioxide in Venus's atmosphere, 3.5% of that is nitrogen gas, and there are small amounts of other gases in Venus's atmosphere. So when we observe Venus with a telescope, what we're seeing is not the surface of Venus, but rather Venus's thick, heavy, dense cloud layer, thick, heavy, dense atmosphere. And that's what we're seeing here. Now, the clouds of Venus are sulfuric acid droplets. Yes, instead of having clouds of water vapor like we do here, they're clouds of sulfuric acid vapor with just a tiny trace of water. So these clouds on Venus are really high and thick up in its atmosphere, ranging from about 30 kilometers to 60 kilometers above Venus's surface. So the surface can't be seen through the clouds, as we just talked about, because of that thick layer of Venus's atmosphere, and because those clouds are so thick. Here are some of the rains on different planets. Depending on what you've got going on in a planet's atmosphere and the temperature of the planet, you can have clouds and therefore rain of different material, different liquids. On the Earth, we have water, liquid water rain, okay? On Venus, we've got sulfuric acid rain. There's an exoplanet called HD 189733b. Some of these exoplanets get funny kind of like zip code names or telephone number names. And this planet is such that it, we think, has rains of glass shards coming down. So what you have is a cloud. In the cloud, you have a collection of some element or molecule that is in sort of a vapor stage. And then some of that vapor starts to condense, and then it rains out, falls out of those clouds. And that's what's happening here when we think about rain, okay? So on Earth, we've got clouds of water vapor, and then some parts of that cloud starts to condense, and that's what falls as the liquid water. That's the rain. And then on Titan, which is the largest moon of Saturn, there are rains of methane gas that condenses out to be liquid methane. Venus's atmosphere is extremely dense, and it reaches pressures of about 100 times that of Earth's at Venus's surface. The lower atmosphere of Venus is very, very hot, with temperatures of about 900 degrees Fahrenheit at the surface. That's hot enough to melt lead on the surface of Venus. Spacecraft have landed on Venus, but they don't survive for very long because of this incredible amount of pressure, this pressure from the atmosphere pushing down on Venus's surface. Here are pictures from a Russian spacecraft called Venera that landed on Venus in the 80s. And it shows, we've got a rocky surface, but it's a barren surface covered with flat, broken rocks, and it's lit up by the pale orange sunlight, the sunlight coming in and sort of being scattered through the clouds of Venus. Sampling from these rocks indicated that they were volcanic. So Venus does have some volcanic activity that's spewing out the carbon dioxide that is very, very thick on the planet. The large amounts of carbon dioxide in Venus's atmosphere create an incredibly strong greenhouse effect. And we've already talked about the greenhouse effect in lab last week. This effect is so strong that Venus's surface is hotter than Mercury's by a lot. although Venus is much further away from the sun. So you might think that the further away you get from the sun, the colder the planet should get. And generally that's true, but it's not the case for Venus. Venus is hotter than Mercury, even though it's further away from the sun than Mercury. Why? It's because of Venus's thick, heavy atmosphere that is made mostly of carbon dioxide that's trapping a lot of that radiation from the sun, and it's distributing that radiation or that heat, that temperature, all over the planet itself. On Earth, we have our liquid water and the life that is on our planet that removes some of the carbon dioxide from our atmosphere, and it replaces it with nitrogen and oxygen, which are the key components of our atmosphere, nitrogen and oxygen. But Venus doesn't have liquid water on its surface. This carbon dioxide has accumulated in its atmosphere. And we just learned that maybe there's some possibility of life on Venus and sort of the cloud layers. We learned about phosphine on Venus, but it's not clear how that might all contribute to Venus's greenhouse effect. The heat from the sun and the incredible amount of carbon dioxide in Venus's atmosphere is what's creating this runaway greenhouse effect, making the planet much too hot. These graphs are comparing the greenhouse effect and atmosphere of Venus and Earth. On these graphs, we've got the temperature on the bottom axis, we've got the height above the atmosphere on the left axis, and the pressure of the atmosphere here on the right axis. So here with Venus, we see that on the surface, we have a temperature of 750 Kelvin. On Earth, on our surface, we have a temperature of about 270 Kelvin, okay? And as we go up in altitude or as we go up in height above the surface, we diminish our temperature in both cases, okay? And the pressure decreases as well as we get higher above the surface. But over here, we see that near the surface of Venus, the pressure is much, much, much more intense than it is on the surface of our own planet. These two charts are showing the atmosphere of Venus and the Earth in comparison. Over here, we have two graphs that are showing us the greenhouse effect comparison between Venus and the Earth. So at Venus, we have incoming solar radiation of 645 watts per meter squared. A watt is a power, a meter squared is an area. So that's power per area. 645 watts per meter squared at Venus as compared to the 342 watts per meter squared at Earth. It's less at Earth because we're further away from the sun than Venus is. But because of all that carbon dioxide in Venus's atmosphere, a lot of that radiation is absorbed into the atmosphere, and because of the efficiency of Venus's greenhouse effect, it heats up the temperature, all that trapped radiation in the atmosphere, heats up the temperature of Venus to 285 degrees Celsius, higher than what it would be if that planet didn't have this greenhouse effect acting in its atmosphere. That's an incredible increase of temperature of the planet because of the carbon dioxide trapping in all of that solar radiation in the atmosphere. Now, if we compare that to our planet, we have a substantially smaller amount of carbon dioxide in our atmosphere, but still enough that the carbon dioxide in our atmosphere contributes to a greenhouse effect, which warms our planet only 31 degrees Celsius above what it would be if we didn't have this greenhouse effect acting on our planet. So actually, without the greenhouse effect on Earth, which is warming us up a little bit by about this 31 degrees Celsius from what we would be without the impact of the greenhouse effect. Without the greenhouse effect, our planet would be pretty cold. It would be much colder than it is now. So the greenhouse effect does help us out a lot. It allows us to have liquid water on the Earth's surface. If we were a little bit too hot, we wouldn't have that liquid water on our surface anymore. If we were a little bit too cold, more of that liquid water would be frozen up in ice. So we are kind of in this really nice sweet spot where we've got just enough greenhouse effect and we're just the right distance away from our host star in order to keep us at a fairly nice temperature and enable us to have liquid water, such is not the case for Venus. The surface of Venus is dominated by volcanic features. Um, it has more volcanoes than any other planet in our solar system. And it has a surface that's about 90% basalt rock. We talked about the Maria on the moon and how the Maria are made mostly of basalt. The Maria were the dark patches on the moon's surface, that those are regions of ancient lava flow. And so if the surface of Venus is mostly basalt, then we know that there must have been volcanic activity on Venus. The current surface of Venus is no more than 50 million years old, although we know our solar system is about 4.5 or 4.6 billion years old. So we've had a lot of volcanic activity in the not too distant past, at least according to our solar system's age on Venus. And some regions on Venus are even less than 10 million years old. And if you have parts of the planet that are at different ages like this, it suggests that part of the planet has been filled in by volcanic activity, kind of lava coming onto the surface from deep inside the interior of the planet, and then that material, that lava bit, cools off, and then that makes that part of the surface a little bit younger because that material just more recently appeared on the surface. Before we end this mini lecture, we're going to talk about the interior of Venus. The interior of Venus is, we think, similar to that of the Earth's. We've got an iron core and a rock mantle. And remember that mantle, at least on the Earth, is sort of like over time, it behaves kind of like a really viscous, thick kind of plastic material. That's the material that's kind of oozing out from inside, coming through with volcanic activity and filling in parts of Venus's surface with lava. Lava flows. So Venus, even though its interior is similar to that of the Earth's, Venus does not show a large magnetic field or a large scale magnetic field like that of the Earth's. Venus's magnetic field is much, 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 much weaker. Why? Well, we think it's because of Venus's slow rotation. The faster you can spin a planet, usually, or even a star, usually the stronger its magnetic field becomes. Venus takes Venus 243 Earth days to rotate once on its axis. 243 Earth days to rotate once on its axis versus us, it takes us 24 hours to rotate once on its axis. And so we think it's the slow rotation of Venus on its axis that results in Venus not really having a very strong interior magnetic field.